Hello and welcome to Virtual Investor Conferences. My name is Eric May, and on behalf of OTC Markets, we're very pleased you have joined us for our next live presentation from VERSS AI Inc. Please note, you can submit questions to the box on the left of the slides. You can also view the company's availability for one-to-one meetings through the Schedule Meetings tab found on the conference platform. At this point, I am very pleased to welcome Gabriel Rene, founder and CEO of VERSSS AI, which trades on the OTCQB venture market under the symbol VRSSF, and also on the SIBO under the symbol VERS. Welcome, Gabriel.
Thank you. Great to be here. I'm the CEO of VERSSS. We founded the company about 6 years ago because we saw this opportunity to build infrastructure for the third era of the web, what we call the spatial web, where an AI-powered version of the web moves into the world around us, powering autonomous vehicles and drones and digital assistants, intelligent applications. We wrote a best-selling book about it in 2019, and you can find that on Amazon if you'd like to see our bigger picture vision for the company and for the future of technology and society. Put together an amazing group of people. Grew up in Silicon Valley working in advanced tech and R&D for 30 years. Pulled together some of the top people in AI and robotics and enterprise software from some of the best deep tech labs, research, and large technology companies in the world. And recruited the world's top neuroscientist, Professor Carl Friston, the man that invented the mathematics behind fMRI scans, which have led to our ability to scan the brain and a deeper understanding of how the human mind works. This is an article from 2018 describing him as a genius neuroscientist who might hold the key to true AI in Wired magazine. We also recruited most of his PhD students over the last couple of years from some of the top colleges in the world. These are really the leaders in what's called computational neuroscience. It's a branch of neuroscience that looks at how you can apply the processes of the mind into software. And really the vision that we saw was not just a world filled with smartphones or smart cars or even smart devices, smart homes, but all rolling up into smart cities that connect into a much smarter world. And how can we ensure that this next era of technology is a benefit to humanity at scale? And so really the key for this next age of a smarter world is in this transition from, in one sense, the information age, we're collecting and connecting data in the web and databases, to the intelligence age, where now it's about analyzing and acting on that data and software that can do that. And that's really the great unlock here, is that AI is the unlock for data, right? And in a way, it's this kind of smart software. It's going to replace and upgrade all software in the world. And not just make devices smarter, but make us smarter, smarter in our businesses, smarter in our decision making, smarter personally, productivity, et cetera. And you're talking, $2 trillion market in the software category just by the end of the decade, according to McKinsey. And this technology is positioned to help us have significant breakthroughs in everything from engineering and science and education, entertainment, and maybe solve some of our real challenges at scale and beyond. The main idea here, I think, that gets lost is that AI is really just about turning data into insights and actions. So raw data comes in, and the ability to have an analysis of information and or the ability to automate activities within the digital physical domain come out. And it's kind of akin to one of the last big breakthroughs in human history, which is around electricity. Sort of captured the power of these natural elements, raw resources, and we built plants that could convert those into electricity, transmit them to users that then have the millions of appliances, the kind of apps of the physical world that use that electricity. And I would say that the top players in the world today in the AI space are really trying to sort of be utility companies. Another thing of this is that instead of that electricity pipeline, AI is just an intelligence pipeline where you take raw data in from human inputs, data from databases, data from sensors, convert that, and essentially AI is a sort of kind of the new sort of power generator. It's an intelligence generator. And then through APIs being the transmission lines that then go to developers that are able to build the millions of applications that will use this sort of structured knowledge and apply it to insights and actions. And so you can think of it as that transition engine, if you will, that's in the electricity realm, sort of power generator that's converting mechanical energy to electrical energy using magnetism, hard science there. And then here you've got a knowledge generator. It's converting data to knowledge, but it's using algorithms to do that. Sort of a digital process of capturing information and translating it. And in a way, there's a very reliable model for this. It's called the DIKW pipeline. But just think of this as a data pipeline, right? So you're taking raw data and sort of unstructured. You're tagging it and you're figuring out what that data is, classifying it. Then you've got to make connections between that. That's what's considered knowledge. Your degrees of context, understanding, and connectedness increasing. Then there's this sort of line, which we call the understanding line, which means that you got to kind of test it out in the world. Once you know that, then you can figure out how to get from A to Z on any problem space, right? And this is really the goal here, is to achieve this level of understanding in terms of how AI understands the human world and how it can apply that knowledge into the real world. And so today we're really at a place where we have artificial narrow intelligence. The goal is to get to general and then even super intelligence, what's often considered, like biological or natural intelligence that learns and adapts. But the challenge today is that the real bar is what we could consider mutual understanding. So we need the machines to understand us. That means understand the human experience, understand our goals, our rules, our values. If we expect them to deliver on the outcomes we want, whether that's to do what we want them to do or not do what we don't want them to do, understanding is actually the prerequisite, which means they have to have a very clear knowledge structure about how they're running that understanding on. What is the basis of that? And then equally, we need to understand their logic. If they're going to be delivering analysis, insights, advice, forecasts, or taking automated or autonomous actions in our physical world, we really need to understand what led them to the decisions that they made or the actions that they took. And this is the current prerequisite that is the challenge for all AI companies today, trying to build this sort of infrastructure layer like VERSes. The problem is all of our colleagues and competitors are taking a very specific approach, which we might call the artificial approach to intelligence. And we feel this is the wrong foundation, both for the sort of smart society and smart world that we want to build together. But it's also really the wrong foundation for intelligence. And here's why. It really relies on this idea of just bigger is better, right? So more data, larger models, increased computational power, right? And that this is going to lead to the kind of understanding we seek. But the problem is just learning words is not the equivalent to understanding the multidimensional human experience, right? And just understanding the sort of data level or the information level of that knowledge spectrum is only gets you partway through the pipeline, right? And sort of just understanding correlations, but not really understanding the causal nature of things, what causes something to happen. This is often when we talk about general intelligence, it's the ability to understand the thing underneath something that lets you understand the underlying causes. And this then lets you generalize from learning one thing to being able to apply that to another, what we might call street smart versus merely book smart. So size does not lead to understanding complexity. Making these things infinitely bigger, from hundreds of millions to now trillions of parameters, does not enable us to understand them better, right? So it leads to worse interpretability, not better. And the fact that they ship GPT and other systems like this in such a way that they are essentially unable to learn in real time. They're just static systems that do not learn, adapt, and evolve. So all intelligence that we're familiar with in the biological world adapts and learns in real time. The current state of AI does not. And so we think there's unknown breakthroughs that are often described as being the key to unlock this kind of general intelligence that would apply to the millions of use cases that developers and creators want to be able to use these systems for. And so VERS has taken a very different approach. This is why we hired a bunch of computational neuroscientists, not just computer scientists. Natural intelligence, following nature's blueprint, sort of first principles approach to AI, would look at AI through the lens of it being able to be multidimensional, understanding lots of different types of information, seeing, hearing, sensing. It's adaptive and learns in real time. It's not massively computationally expensive. It's actually hyper efficient. And you even get the benefit of these things being able to work with other agents at scale. So nature tends to like collectives. And that's what we cracked, is the underlying first principles that have led to a type of understanding of the human mind, of how neurons work in the brain. And we've applied that to our software systems. And we're the only ones on the planet really to have been able to do this and apply this so that it can scale. You might think of this as the underlying neurodynamics, in the same way, say, the Wright brothers sought to understand the aerodynamics when they built the first plane. Everyone else was building flapping winged planes. These guys built a wind tunnel in a barn. Said, let's try to understand, how nature does it, and then apply that. And that's what we've done. We've essentially been able to understand the underlying structure, dynamics, and processes in biological intelligence and apply those to software for the first time. This is based on the research of Professor Carl Friston, as I indicated, and his researchers that we have now in the company. It's called the free energy principle, of what's called active inference. You might think of this as the ability for an intelligent thing to infer, sort of make guesses actively, constantly, in real time about the world, and learn and test those to see what works. It's essentially, again, that sort of book smart versus street smart thing. Being able to actually know how to apply knowledge in the world is a key factor for intelligence. And this is not just theory. We've actually been able to demonstrate the hard science on this. So in August, Nature magazine, one of the top magazines in science magazines in the world, we demonstrated neurons in a petri dish being triggered with electrical signals, and the free energy principle, that Professor Friston's underlying algorithm for intelligence, was able to perfectly predict the process in which neurons self-organize or update and learn. So this is what learning is in the brain. And it basically tracked that perfectly, much like the laws of motion will let you predict, how a bullet will move through space. This can be used to create next generation artificial intelligences that learn as real neural networks do, not the type of artificial neural networks that are the standard or state of the art today. This is a significant breakthrough, not only scientifically, but in the engineering approach we've taken at VERSS to apply this. So what you get is not just sort of narrow intelligent AIs that might learn one or two tools, but can't learn and adapt in real time, but rather general intelligent agents that can learn generally anything and can learn and adapt like biological intelligence does. Now, the reason everyone in the space is trying to get to this AGI, general intelligence level, is that the company that cracks the code on general intelligence enables a set of features that all of the sort of vertical players can't do. And so you enable hundreds or thousands of competitors around the vertical sort of AI space. This is why the best possible place to invest in terms of the AI markets is to invest at the infrastructure level, because advances at the infrastructure level basically eclipse many of the innovations that will happen in the verticals, enabling real powerful markets and many, many millions of applications, just as we've seen in the sort of Web 2.0 era with mobile applications, right? And so what we've done is we've taken all of this and applied this to our technology. And we've built a new platform, intelligence as a service, called Genius. The idea of applying the genius of nature to software systems. So this is based on the biological algorithms that Professor Friston and our team. It's a combination of Silicon Valley engineering and a major sort of global academic rigor. And so what Genius is a next generation approach to intelligent software. You can think of this like much like the electric company or the power plant. We're offering intelligence as a service. This allows the ability to take any data set, not just public data, which the rest of these systems work on, but rather personal data, private data, corporate data, and teach it our agent platform to basically be able to generate an agent for you. So now you can customize an agent for any use case. They can learn not just text-based information, but multi-sensory data, even three-dimensional environments. They're based on these biological algorithms. The benefits is that now you get the kinds of insights and actions, right? Data goes in, insights come out. So you get the ability to have intelligent querying, analysis, recommendation engines, prediction engines built into any kind of software platform. And you can get everything from digital assistants by combining these with other things like large language models that talk nice but don't reason that well. So you get the best of both worlds, and robotic automation, everything from autonomous, cars and drones and ships and vehicles and intelligent supply chains at scale. This is really the sci-fi version of the types of artificial intelligence that we've always sort of hoped for. Importantly, we've also put the precautions in to sort of help us avoid the sci-fi dystopic nightmares that we'd all want to avoid, which I'll talk about briefly in a few minutes. First, let me just sort of summarize. What we have here is a smarter kind of software, right? And what VERS has done with the Genius product, which we just launched this month in beta, we'll be running in a private beta with 10 customers, some Fortune 500s, small devs across 10 different industries over the next 6 months. You've got this new approach that aligns the logical and physical understanding of the world, right? Where you get that mutual understanding. So both now these things can understand the multidimensional experience of humans, our rules, our values, our goals. They can learn and reason and adapt. But critically, we can also understand, because of the explicit way that we model data in our system, what their thinking is, if you will, and can basically prevent certain activities that do not align with those rules. If we look at the market today versus competitors are multi-billion-dollar companies that, for the large part, didn't have these valuations 12 months ago. Now AI has become the most valuable, interesting market in the world. In fact, even these numbers are wrong now, just over the last week or so as I've been presenting this. What you should know is that all these companies follow the exact same approach, that sort of artificial foundational approach to building these what they call foundation models. And there's a reason for this. It's because it's largely worked for the last 10 years. And so this is a t-shirt people in Silicon Valley actually wear. It says "Scale is all you need. AGI, general intelligence, is coming. Just add more compute, bigger data, more parameters." And so this philosophy, though, has produced some amazing results. You get things like ChatGPT and some incredible generative AI models. But there's a huge problem. They've all trained on the exact same data set. It's essentially just public data cured from the web. You can kind of think of Google has indexed the web as a search engine for you to be able to use, that gives you a list of results. ChatGPT and the rest have basically curated essentially the same data set, where you've got kind of a smart search engine that can generate much better results for you. But it's trained on less than 5% of the data that's out there. This is because most data is behind a password or a login. And so these systems do not translate very well to being able to be useful for you, for your data, for your company's data, for your investment thesis, for as a personal trainer for you, as a mentor educator for a child. So the ability to customize and personalize an intelligent software on 95% of the data that's out there in the world across every enterprise, business, and industrial player, Fortune 500, that gap is still quite big. And Genius is designed to operate on that. Instead of you using their AIs, we are giving you the tools, or rather developers the tools, to build solutions for you. Right? This is the difference between the supercomputer of IBM in the 70s and the personal computer that ended up in your pocket. Right? This is the difference between AOL being a single portal to the internet in Web 1.0, and Netscape that came out and said, "Hey, here's a way for people to basically access all of the web." We know who won those wars, and we think we're well positioned to win this one. One of the other problems of merely making everything bigger is that you've sucked in a bunch of data that you probably shouldn't have. So on top of the issues they have around accuracy and bias and explainability, because they're just giant black boxes, they also have legality issues. So Wall Street Journal and New York Times and Sarah Silverman and Stephen King all suing them, and they can't really figure out how to go in there and easily pull that out because it's this massive multi-trillion parameter sort of spreadsheet in the sky. Of course, this turns into the governability issues, which we've seen every government around the world, including this last week in the UK, pulling leaders together in the companies to try to determine how do we ensure that these things do what we want them to do and don't do the things we don't want them to do. And the answers right now are not very good. Why is this? How come the best companies in the world have produced a product so amazing but with so many problems? It's because they're all sort of following the blueprint of one man. This is the godfather of AI. This is Professor Jeffrey Hinton, who basically became the head of Google AI. And what I want you to see here is that Professor Hinton started the computer science lab at University College London in the early 2000s. His students created a group called DeepMind based on his, let's call it, scale approach, this idea of scaling more data, more compute. They all ended up at Google. in 2015. And this really kicked off the modern wave of AI. And then you saw that team make innovations with the ability to play games like Go. And then Elon and others said, look, we need an alternative to that. Let's not just sort of close corporate AI that might be smarter than everybody else on the planet, the sort of nuclear arms race of the modern era. And they formed OpenAI as a counterpoint. And they took some of the people from Google AI to do that. Well, now all of the other foundation models that you've seen here have done the same thing. Inflection, Cohere, even Anthropic is ex OpenAI people. Even Elon's new company, XAI, is actually all people. It all comes from Google AI, and they're all basically following the Hinton script, which is bigger is better. What the story that you don't know, which is about to come out soon, is that there's right next to the computer science lab at University College London is the neuroscience lab, where Professor Friston has been making breakthroughs in natural intelligence. And these two gentlemen met on occasion to talk about the differences between artificial and natural intelligence. One day, in fact, I think their last conversation, as Professor Hinton on the right was describing some of his latest thinking on how to scale and mimic human intelligence, Professor Friston said, yeah, but the brain only uses 20 watts. So there must be something wrong, something we don't understand in our engineering approach here that isn't getting us to the way nature does it. His students formed a group, not DeepMind, but called Nested Minds, the idea that intelligence is actually hierarchical. The world is structured in these sort of dynamic ways. And VERS has actually acquired them instead of Google. We formed a nonprofit foundation where we built these underlying modeling language structures that allow open and standardized ways of modeling information for artificial intelligence that do allow them to be governable. We donated this to the IEEE, who's the largest standards body in the world. And we're the only ones now with this sort of open approach. We've built our Genius platform on top of this, and that's the proprietary layer that has been developed now in these open standards. Kind of what the idea was of OpenAI, but we believe fulfilled in a much better way. So what you end up with is, the godfather of AI leaving in order to come out and say, I've kind of made a horrible mistake. And I think these things are going to take over the world if we're not smart. But they're giant black boxes we don't understand because that's how they were designed based on my work. And now, not offering a whole lot in the way of solutions, but at least ringing the bell. I think we share some of those concerns. The real question here has generative AI and these foundation models sort of hit their peak in 1 year, right? Certainly the promise is significant, and the multi-trillion-dollar opportunity is clearly still there. But this is Gartner's hype cycle. There's a cycle that all technologies go through where they're unknown, then the public kind of finds out, there's tons of interest, there's tons of investment, then they've got to kind of dip down into the trough of disillusionment here before they climb back up to really building a mass market. And this is the case, even we saw this with smartphones. You'll see generative AI up here. Down at the bottom left, you can see first principles AI. That describes what we're doing. First principles based on nature. And the truth is, if you see things up here like artificial general intelligence or composite AI, the fact that you can put multiple AIs together, or causal AI that understands the underlying causes of information, or multi-agent systems, all of these are based on a first principles approach. First principles is a far better foundation than merely engineering a solution. And so we think that this puts us in a perfect position to not only sort of address some of the shortcomings of the current systems, but be a far better foundation for this multi-trillion-dollar market opportunity. And why is this? It's because all these things trained on words. And we've designed a system that basically trains on multi-dimensional data and can learn and update its understanding as the world evolves, because the world is not a static thing. And so just looking back at the history of all of the patterns extracted from words is a powerful tool, but it's not really an infrastructure. And so what you get is, with VERS, is a smarter approach to intelligence. It's based on how natural intelligence works, based on hard science, not just on engineering. And it can use these generative AI capabilities as tools. One's a great computer vision model, one talks really nicely, et cetera, and can compose these together. But now you've got a quarterback on the field who can call the play, not just a bunch of players hoping to run their next play based on whatever worked, for the last few years here. And more importantly, they can even work with the other agents. So across what we're building, a Genius platform enables a network. This is that spatial web we talked about, sort of third version of the web, where you got a network of collective intelligence, of artificial intelligence systems built into the sort of new era of the World Wide Web. And so this really puts us on a path. Is it the artificial path or is it the natural path? Do we want to scale one giant machine that one company or one country controls, just bigger data, bigger models? Or do we want to grow an ecosystem using small data, smaller models with much richer data sets that are far more accurate and adaptive? Finally, we put together a something in these systems. We've standardized these data sets that align with where the global governments are going, because AI is going to be a highly regulated industry. This is the G7 calling for international technical standards in standards development organizations through a multi-stakeholder process in order to basically, decide on global standards for AI. And this is exactly what groups like the IEEE have been doing for years, right? Standardized Bluetooth, standardized Ethernet, standardized Wi-Fi. And that enables a whole ecosystem of developers and manufacturers to have guarantees about the underlying technology, how to be compliant, and for consumers and users to know that, wherever they go, their systems will basically be interoperable. So we did this several years ago, started developing the underlying modeling language that enables the hyperspatial or multi-dimensional data sets to be able to work together. We donated that to the IEEE for the same reason. We also put out a report recently, about 2 months ago. We have a webinar coming up here on the 9th, which we welcome you to join, with Denton's, the largest law firm in the world. We were just at the Georgia State Legislature yesterday, talking with them about this paper, The Future of Global AI Governance, that calls for the IEEE standards to be the basis for global AI regulation, global AI governance. Why? Because it enables that understanding, not just AI is able to understand the multidimensionality of our world, but because we model it in this explicit way rather than this big data sort of black box way, you've got a glass box that allows us to understand their decision-making process and enables the kind of compliance controls that we need in order to really scale these technologies. Finally, quick snapshot of our roadmap. We've gone into the Genius Beta. This is going to be 10 hand-selected customers across multiple industries, from small developers to Fortune 500s. The goal is to get testimonials and case studies, harden up the technology so that in the spring of next year, we can roll this out and developers can start using it for themselves. This is going to be a consumption model, very similar to the way we're seeing OpenAI and others do it. The more you use, again, kind of like a utility company, the more you pay. An amazing board, myself and my co-founder, as well as Jay Samet, the former vice chair of Deloitte, Scott Patterson and John DeVos, both strong backgrounds in both Canadian and London investment world. And quick snapshot of the cap table. Founders own about 63 out of 147 or so total outstanding shares. About 60 million raised over the last 2.5 years. It's mostly Canadian numbers here. Took the company public last June. You can see where it's currently trading today. The SIBO is the Canadian ticker VERS, and the OTCQB VRSSF at present. And just to wrap up, before we take a couple questions, what is the right foundation for the most disruptive technology in history, right? It turns out that building on this sort of artificial foundation comes with lots of challenges and lots of risks. But we think we're better positioned to be the underlying foundational layer for this, in part because we're standards-based. And it took things like the IEEE making grounding wires, 100 years ago in electrical systems that allowed electricity to scale to where we are today. Well, now intelligence is the kind of the new electricity. And we think that VERS is best positioned for the fact that it's standards based, that we enable this mutual understanding, and this enables compliance and with our laws and rules. Beyond that, I would like to point out that we're the only horizontal foundational player in the public markets. So as an investor, if you're interested in catching this AI wave and want to see some part of this multi-trillion-dollar opportunity before these other companies may or may not go public in 6-7 years, you can pick a vertical player, but as we indicated, those that come out with foundational generalizable capabilities might eclipse them. So Versus is really the only underlying foundational player in the public markets. And we think that that gives us a perfect foundation for the future. We hope you'll join us. Okay, let's take a question or so, and then we're happy to follow up with any other questions. Lots of questions here. These are great. Can you share your thoughts on the White House AI executive order? Well, this is obviously very timely. So the executive order is I would say, good start, but largely toothless. And this is why, and we talk about this in the paper with Denton's, we'll be actually going over the White House executive order on the webinar with the Denton's team in a couple of days. So you can get more information on our website there. The real problem is that we're talking about technologies that are intended to become autonomous, meaning they will make their own decisions and take their own actions, like an autonomous car. You're not telling it make a left turn, stop, go. That's going to apply to everything: electrical grids, our financial systems, and so ultimately merely setting up obligations for companies, say we're going to fine you if you don't, if these things get out of hand, doesn't control the AIs themselves. What we're proposing with standards is a way to basically enable that. And that's why we were at the Georgia State Legislature, and we'll be talking to members of the AI caucus, because we think that this is the only real route forward. Anyway, thank you very much for your time. I think we're getting a list of your questions, so we'll try to follow up with folks on any of those, and look forward to seeing you guys on our webinar. And please stay tuned to all information over at VERSSSF.